Greetings! Welcome to Pablo Hidalgo's tutorials and my free CCNA complete course, now in English. Today I bring you the lesson number 3, Physical Layer with Cooper. In the previous lesson, I presented a hybrid 5 layers model that describes the way the different protocols interact in a data network. This model is constructed using the application and transport layers from the TCP/IP module and the network, data link, and physical layer from the OSI module. The OSI physical layer provides the means to transport bits. This layer accepts a complete frame from the data link layer and encodes it as a series of signals that are transmitted to the local media. The physical layer encodes the frames and creates the electrical, optical, or radio wave signals that represent the bits in each frame. These signals are then sent over the media, one at a time. Many different international and national organizations, regulatory government organizations, and private companies are involved in establishing and maintaining physical layer standards. To name a few of them, we have International Organization for Standardization, Telecommunications Industry Association, Electronics Industries Association. We also have the International Telecommunication Union, American National Standards Institute, Institute of Electrical and Electronics Engineer, and also several national regulatory authorities. For example, the Federal Communications Commission in the US and the European Telecommunications Standard Institute for the European Union. Bandwidth is the capacity at which a medium can carry data. Digital bandwidth measures the amount of data that can flow from one place to another place in a given amount of time. Bandwidth is typically measured in kilobits per second, megabits per second, or gigabits per second. Cooper cabling is the most common type of cabling used in networks today. Data is transmitted on Cooper cables as electrical pulses. Unshielded twisted pair cabling, or UTP cable, consists of 4 pairs of color-coded wires that have been twisted together. Each pair consists of one conductor of solid color and a second conductor, which is white with a stripe of the other color. The colors of the wire pairs in the cable in order are blue for pair number 1, orange for pair number 2, green for pair number 3, and brown for pair number 4. UTP cabling, terminated with RG45 connectors, is used for interconnected network hosts with intermediary network devices, such as switches and routers. The twisting of the wires helps protect against signals interference from the other wires. Any electrical presence in the cable that it is not the signal itself is considered noise and constitutes a threat to the integrity of the signal. Many sources of noise exist from within and outside the cable. Electromagnetic interference (EMI) and radio frequency interference (RFI) can distort and corrupt the data signals being carried by Cooper media. Potential sources of EMI and RFI include radio waves and electromagnetic devices such as fluorescent lights or big electric motors. When a pair is in use, an electric field is created around the cable. This electrical field induces voltage in adjacent pairs. With the transfer of the signal, the more parallel the conductors, the worse this effect is, and the higher the frequency, the more likely crosstalk will happen. Twisting the two conductors of a pair around each other cancels these electrical fields and minimizes the damage caused by crosstalk. ANSI TIA 568 is a technical standard for commercial buildings cabling for telecommunication products and services. This standard defines 2 alternative pinouts for cable termination. First, we have T568A, And then we have T568B. The difference between A and B pinouts is that the orange and green wire pairs are exchanged, as you can see in the diagrams on the screen. The electrical characteristics of Cooper cabling are defined by the Institute of Electrical and Electronics Engineers, or IEEE. The IEEE rates UTP cabling according to its performance. Cables are placed into categories based on their ability to carry various bandwidth rates. Cables in higher categories are designed and constructed to support higher data rates. As new gigabit speed Ethernet technologies are being developed and adopted, Category 5E is now the minimally acceptable cable type, with Category 6 being the recommended type for new building installations. For correct transmission over the link, the wires in the UTP cable must be connected to the correct pin positions in the RJ45 connectors. Ethernet NIC transmitters on hosts like PCs, servers, and even routers use the pair connected to pins 1 and 2, while the NIC receivers use the pair of wires at pins 3 and 6. LAN switches do the opposite. Their receivers use the wire pairs at pins 1 and 2, and their transmitters use the wire pair at pins 3 and 6. To allow a PC or server NIC to communicate with a switch, the UTP cable must use a straight-through cable pinout. This also applies for routers. If you need to connect a router to a layer 2 switch, you must use a straight-through cable pinout. An Ethernet straight-through cable uses the same termination T568A or T568B on both ends of the cable. The crossover cable is used to interconnect similar devices. For example, to connect a switch to another switch, to connect a PC to another PC, or to connect a router to another router. The crossover cable pinout crosses the pair at the transmit pins on each device to the receive pins on the opposite device. You must use different termination on both ends of the cable. For example, T568A on one side and T568B on the other side. However, crossover cables are not considered legacy, as modern NICs can automatically detect the cable type and make the internal connections. You may follow me on Twitter or X and also on LinkedIn. And please subscribe to the channel if you are not already a subscriber. Also, you may consider joining as a member, so you may support me to continue create more videos. For our next lesson, I will continue with the physical layer unit, and I will present you fiber optics. Thanks for viewing. See you in the next lesson. Goodbye.